Hello, my name is Yingzhuo, a PhD candidate working in KTH. I'm one of the DCs in SciENC, and this is a video introducing my work about satellite wireless communication. And the topic of my work is satellite selection and resource allocation in low Earth orbit satellite networks. Okay, let's start from the background. So first, what is a low Earth orbit satellite? The definition of it is a satellite with an orbital height of 500 to 2,000 kilometers. Then, what characteristics do LEO communication networks have? The advantages of it are low round-trip delay, which is about 30 to 50 milliseconds, and low cost. And round-trip delay is the total time it takes for a signal to go from a ground terminal to the satellite and back to the ground terminal. And when I say LEO has very low round-trip delay, low is relative here, compared with middle Earth orbits or geostationary Earth orbit satellites. And the disadvantages can be summarized as high network complexity and limited communication resources on satellites. And to overcome the disadvantages of LEO communication, we need to put more effort on selecting the satellites and allocating the resources properly. And here is a very short video I took from the simulation software. I try to use this video to explain why the multi-orbit LEO communication network can be really complex and hard to manage. So the first point is that we can see the projection on the Earth's surface of the orbits are always drifting and not relatively stationary with the Earth. And the second point is that the satellites moving over the users and which are visible for users are from different orbits. In this page, I will give you a very rough idea about the problem. I summarize what we're gonna do at four steps. First, we will select serving satellites. For example, in this picture, the orange satellites are selected to provide the service. And second, we will do user association to decide which satellite serves which user. And the third step is that we will do bandwidth allocation to decide which subcarrier serves which user. And the final step is we will do power allocation to decide how much transmission power is allocated to each user. And in my problem, the objective is the sum rate of the network. And here is the algorithm design. And as there are two main parts of the proposed algorithm, the orange block and the light blue block. And here CO is the counter of the iterations. And the function of the orange one is producing the satellite selection, which can bring higher sum rates with higher probability. And about the light blue one, the input of the part is satellite selection given by the orange block. The output is the association results and allocation results. The method used here is called alternative optimization. And the design of the orange block is based on Markov approximation, which is proposed by this reference, by this citation here. And so here we come to the simulation, and we had a simulation over a constellation with 1,000 satellites. And here is a parameter table of our simulation. And in this slide, we have the satellite selection at different time instances. The time interval between each pair of figures is 4 minutes. And the top row is a two-dimensional top view, and the bottom row is a three-dimensional view. And so first, uh, after observing the simulation results, we can find that the satellite's distribution of users is changing fast and quite time varying. A second, look at figure E and figure F. The selection result here is against our intuition. Two satellites which is not about the area are selected because some users which are distributed at the edge of the area, and which means that the simple rule can be lose a function at some kind of situation like here. So finally, thank you for watching this video, and here are our publications.